sphere of fissile material would escape out and not be reflected back, and it would stop the reaction. If you closed the blinds, the neutrons would strike the graphite, go back into the sphere, and cause the nuclear reaction to continue. And by opening or shutting the blinds, you could control the amount of heat being produced by this barely subcritical bomb. And they launched, I'm not certain how many, around a dozen of them that were up there. One of them crashed in Canada about 20 years ago, and they cleaned up the mess the Canadians did and sent the bill to the Soviet Union at the time. But the rest of them were parked in high orbits around the planet, and with decay periods for those orbits on the order of 300 to 400 years. So I'm not certain when they're going to be coming down, and I'm not the one who monitors those orbits. But yes, that's a concern that we will have in 300 or 400 years from now, if we're still here.
If we're still here, if the CERN particle accelerator doesn't eat us up, right?
Correct.
Let's go to the phones. We'll go east of the Rockies. Jay in Houston, it's your turn. Hi, Jay.
I guess you've seen on the news we have a large sinkhole up here in Desetta, which is now 900 feet.
Yeah, I just saw that. If you like Florida these days.
Should we be thankful here in Texas that the funding was cut for the superconducting super collider after they spent $1 billion digging a 56-mile around tunnel? Would that have created the similar?
It would have been the exact same machine that they were building there, almost exactly the same thing. In fact, it's the same people working at it. When the funding was cut, Fermilab was going to be building the machine down there at Waxahachie, and when the funding was cut, they looked elsewhere, and they got in touch with the people up at CERN and decided that they would put the same machine in an existing tunnel and save a lot of money. So it actually ended up costing less money to do that, but it did delay it, which gave me the opportunity, more time to get my act together, so to speak, and raising the consciousness about this.
So the tunnel at CERN was already in existence before they started building this?
Yes, that's correct. There had been a previous collider, but it was colliding electrons and positrons. And it was nowhere near the energy of this one. And so that was scrapped. They finished the last run about 7 years back. I forget exactly when it was. And they then started working on installing the equipment for the Large Hadron Collider in the existing tunnel.
So would this one in Texas have been more powerful?
It would have, as I understand it, would have made maybe about twice the energy. Wow. Is all, a little bit more, and that's about it.
Wow. I guess we should be grateful for cutting
something.
Yeah, well, it did delay things, and for that I'm glad. It gave me the opportunity to get more theorists out there thinking about this. We've got a lot more research under our belt showing that these adverse scenarios are something that is an actuality that we can't discount. And so we've had a lot more time to think about it and to get this information out there than we'd had previously.
Next up, wildcard line, Kent in South Carolina. Welcome to the program. Hi, Kent.
Hey, gentlemen. I'm really pleased to have the chance to speak with you tonight.
Thank you.
I'm a little confused on a microscopic black hole. I mean, it seems to me that, just from what I understand, isn't like a string potential compared with the known universe interchangeable, and a string potentially would create a quantum singularity. At that rate, it seems like to me the more mass you dump into a black hole, it's a paradox. Doesn't it constrict and become even smaller because of its mass and the gravity squunching it up smaller? So with that in mind, when you say you can take a few particles of an atom and make a microscopic black hole, wouldn't it be like the converse? It would be bigger because there's not as much mass to introduce the gravity to squunch it down small. You see what I'm saying?
Yeah, I understand where you're coming from, and no, that's not quite correct. The black holes were first conceptualized from the idea of a star that collapses under its own gravitational pull, and normally it would take a star about 3 times the size of our sun, 3 to 4 times the size of our sun, in order to form a black hole. But the mathematical theory that goes along with this doesn't have a lower limit on the actual mass you could have for a black hole. It simply describes it at any mass you want it to be, and then it describes its diameter as being what's called the Schwarzschild radius, and that gets smaller and smaller with the less amount of mass you have available for the black hole. So the microscopic ones that the LHC would have an extremely tiny diameter, because they would not have very much mass inside of them. They would only have a few thousand atoms worth of mass, but it would be in a diameter that would be a millionth of the diameter of a proton, or thereabouts. And so it would have a very high density within its volume, but it would be very, very tiny. And so the problem is how to create one. Normally, you have to have a star that collapses under its own gravitational field. But some theories show that by scrunching matter together at very, very high speed, that you might be able to squeeze the matter together tight enough that it also forms a black hole.
Do you know if Stephen Hawking has reacted to the CERN project?
Yes, I've heard one comment from him, and it was apparently he's not keeping up with what's going on. He commented that he wasn't concerned because of the cosmic ray argument, and the cosmic ray argument has been debunked initially by myself and my associates, and subsequently it was also debunked by what's called the LHC, Large Hadron Collider Safety Assessment Group, who came out with the exact same conclusion we did, that in nature, cosmic rays that would tend to mimic what's being done at the LHC, when they strike the Earth's upper atmosphere, they are moving at very, very high speed, very close to the speed of light, and if they create micro black holes in nature, the micro black hole would be traveling at the speed of light, or very close to the speed of light, and travel right through the Earth, and because they are very neutrino-like, it would not interact, other than maybe one atom would be taken away from the Earth, and that would be it, and then it would exit on the other side, and we'd never be any the wiser.
Let's go west of the Rockies. We've got John in Santa Barbara, California. Hi, John.
Hi, George, Dr. Wagner. Well, I just had a quick observation that if this fellow who said that it would take 5 years to swallow the Earth, that would tie right in with the Mayan calendar thing.
Yeah, that's sort of bizarre. I haven't seen his calculations as to how he came up with 5 years, and I don't think you could set any firm time. I think that was an estimate that he made as to the minimum time, and I don't think he was saying that it would be exactly 5 years. Just that I think he came up with an estimate that it couldn't be less than 5 years.
I'm not sure the Mayans knew about this, but I'll tell you, it is weird how everything seems to be getting close to that date.
Yeah.
First-time caller line, Steve in Indianapolis. Go ahead, Steve.
Morning, guys.
Hi.
I have no training at all in physics, but I'm hugely interested, and I'm afraid I'm not going to be as eloquent as I need to be. But for years, they've been searching for the theory that ties, the two theories together. The reason, in my opinion, the reason they haven't found one is because one of the two theories has to be wrong. And I believe that the one that is wrong is Einstein. When the automobile was first invented, the common
Belief
was, thank you.
There you go.
The common belief was you couldn't go faster than a mile a minute because it would suck the air out of your lungs. Then